Hello, everyone. Good morning, good evening. We have Rob Richardson. Rob, thank you for taking out time from your busy schedule and agreeing to deliver a session at the symposium today. Over to you, Rob.
Sounds great. I saw the slide come up and I'm like, hey, I know that guy. He's awesome. Let me share my screen and let's dig in. Database DevOps with containers. I am so excited that I get to share this with you. We'll get to look at how do we get SQL Server to be able to deliver content from production into developers or non-production environments safely. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. You may go look on my site tomorrow, next week. I've been that guy chasing the speaker and I chased him for 6 months. And by the time he finally replied, he said, oh, yeah, I don't even have those anymore. Which is why you can go to robrich.org right now and go view these slides and code. Let's head over to robrich.org. We'll click on presentations here at the top. And here's Database DevOps with containers. The slides and the code up on GitHub is online right now. Achievement unlocked. Woohoo! So next up, let's hit About Me and talk about some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate, a single store developer evangelist, and let me tell you about AZ Give Camp. AZ Give Camp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver that completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp in your neighborhood, hit me up on email or on Twitter, and let's get philanthropy installed in your neighborhood as well. Some of the other things that I've done, SQL Source Control Basics, mine is Chapter 8. That was a lot of fun to put together. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame. And if you'd like a coveted .NET, no, I'm just kidding. So let's dig into database DevOps with containers. Now, our goal with DevOps is usually to get applications from developers' hands to production. But really, our goal is about automation, reliability, consistency, and cost. It wasn't always the case, but machines are cheaper than people now. So let's get the machines to run these things. And then when it comes time for the people to intervene, then we can use those more expensive resources to be able to tidy up the corners. Automate all the things. Really, I want to be able to sleep. Let's let the machines do it so that when an urgent request comes, we don't need to. Because computers are cheaper than people. I recall the stories in the 50s where people would read through their punch cards and run the unit tests in their head. And that's interesting. But that's not the world we live in today. It's faster for us to rerun all the unit tests than for a user to look at them a second time. A DevOps pipeline. Let's take a look at a typical DevOps pipeline. Here's a DevOps pipeline for applications. Now, the interesting thing here is that we start with a user suggestion and we end with delivering value to users and getting their feedback. If your DevOps pipeline doesn't start and end with users, I would invite you to add users to that DevOps pipeline. We're building software for users. We're delivering value to users. And so having them part of our DevOps pipeline is really important. Now, this is a DevOps pipeline for applications. Let's take a look at it. We start with a user suggestion. A developer will pick a task off the task board and start coding that content. Ultimately, they'll commit that content back to source control, and it will kick off a build. The build will do a whole lot of tasks. Maybe it'll run tests. And ultimately, it will deploy probably to a pre-production environment, maybe a dev or QA or test server. Now we can get QA to go validate that this works as expected. And for the most part, let's see if we can get automation to do this, but we may need a person to give it the thumbs up. Once QA gives it the thumbs up, then we get to push to production, where users get to experience this feature and provide us their feedback. Given their feedback, that becomes suggestions that we can run in this process as well. Now, this DevOps pipeline is great. It allows us to deliver application features from user suggestions all the way to delivering value back to users. Now, what if something fails? What if there's a test that fails? Now, in that case, the DevOps pipeline stops here, and we can go back to the beginning. Now, in this case, maybe a test failing is feedback for a user, a developer, rather than a user of our software. But we can stop at any point and take that feedback and use that to improve our process. Production users are not impacted with a failure because we have this DevOps pipeline. Now, when we talk about moving left, the goal is that we can fail this process as quickly as possible. Wouldn't it be neat if developers could learn that their system is failing before the build server needs to notice? Probably while they're coding. That would be ideal. Let's shift left to be able to provide as much detail as we can. Now, that's the DevOps pipeline for applications. And I would ask you, where's the master copy? If we were to lose everything else, could we get back with just one thing? For the most part, when in an application DevOps pipeline, the master copy is our source code repository. If we lose everything else, we can take that source code repository, we can rebuild the application, we can run the tests, we can deploy it to a pre-prod environment, QA can give it the thumbs up, and we can put it back in production. But if we lose source code, then we're stuck. I've had some projects where we do lose the source code and all we have is the production runtime. And they're like, can you upgrade it? Maybe, probably not. So that's the DevOps pipeline for applications. Now let's turn it on our head. What is the master copy for databases? Now, you may want to point at the source code, and ideally checking in the schema and lookup data enumerations would be important. But the master copy in this case is not source code. The master copy is our production database. If we lose customer data, it doesn't matter how much schema we have. Production is really the master copy here. So let's use that knowledge to build up a DevOps pipeline where we can start with production data and populate the rest of these environments. Let's zoom in a little bit and take a look at a DevOps pipeline for databases. Now, it is important for us to take the source code from a developer, run it through a build process into a pre-production environment, and ultimately deploy those migrations into production. But let's take a look at a different migration process. Let's start with production. Now, if we take a production database and we just run it through this cycle, that might be disaster recovery. Maybe we had an unfortunate where clause that deleted too much data and we need to get back. Or maybe we had a hardware failure. So we'll back up production and we'll restore it to production. That's a perfect DevOps pipeline for databases. Do we do that in an automated way? Let's step out to the next one. In a pre-production environment, we need to take a production backup and we need to restore it to a pre-prod environment. Now, as we go to pre-prod, we may need to do some additional things. Sanitize, anonymize, and shrink our database appropriate for this environment. Maybe in pre-prod, we're changing out connection strings so that we get at the particular setting that we need. Or maybe we're changing out API keys to hit the API's staging environment instead of a production environment. Or maybe we're not changing anything at all. As we get farther down the dev test server, we probably need to anonymize, sanitize, and shrink more. We probably don't have as beefy hardware here in our dev and test environment, so maybe we need to delete some data. Now, let's not delete all the weirdness. That would give us a false sense of security, but let's delete maybe the biggest customers, number 6 through 10, not the biggest customer, but some big customers. Maybe we'll truncate log tables just to remove the beef of the database without changing the query shapes and experience. We'll probably want to anonymize and sanitize the data too. We don't want to get customer data into the hands of developers that might get lost. Or if I'm testing the email send system, I don't want to send emails to real users. We probably also want to sanitize the data to change API keys. And next up, developers. Now, ideally, developers can work in their own environment. They don't need a shared database server. Imagine if we had, well, Visual Studio. And we started out our day opening up Visual Studio, and we went to the shared file share, and we opened up that project inside Visual Studio, and we started coding from the shared drive. Now imagine another developer does exactly the same thing. How's that going to work? Well, we're probably changing different files. So when I build, the other person is stuck. And when the other person builds, I'm stuck. That's what we do when we have a shared database, is we're clobbering each other with interesting things. Let's see if we can create a DevOps pipeline that can create a database for developers that is appropriate to the hardware that they have. We don't have lots of scaled out hardware here. We just have a developer workstation. But can we anonymize, sanitize, and shrink this data appropriate for this environment so that developers can work in their own isolated environment? I love Grant Fitchie's comment here. Give developers their own database so that they can burn it to the ground without having to wake you up for a new one. So with each of these environments, we have different tasks that we need to do, and to different levels. We need to anonymize, sanitize, and shrink the data. Anonymize it by changing customer data so that we don't expose private information. Sanitize the data. Let's change secrets like API keys. Shrink the data. Let's delete bulk data in interesting ways without changing the query shape. We don't want to give the developer a false sense of security by deleting all big customers. We want them to be able to experience the pain of their queries in the normal way that they would in production. Now they'll code their queries differently, perhaps creating indexes or optimizing their where clause to be able to take advantage of content. But we don't want a really big database. If we have a 5 terabyte database that we're trying to put on each developer laptop, that's probably a non-starter. So we'll sanitize, anonymize, and shrink the data appropriate to each environment. Once we get there, let's migrate that database to the latest version and validate that that data works as expected. Now on a developer's laptop, we'll probably do a lot of anonymized, sanitizing, and shrinking. In a dev test server, we can do that a little bit less. We still want to be able to sanitize customer data and change the API keys, but maybe we have beefier hardware and we can leave a lot more data. And then let's run all of our migration scripts to get to our latest version, and then run all of our unit and integration tests to be able to validate that this database works as expected. Now, the interesting part here is we just migrated to the latest version. We just practiced a production deployment. That's kind of cool. Every time we run this DevOps pipeline, we are practicing our production deployment by running all of those migrations. Very nice. Automate all the things. So as we do this process, now we're able to sleep. I love that. Let's create these processes that kick off automatically, perhaps every night shortly after the production backup finishes, and is able to create these images inside of different environments to be able to do amazing things. So how can we automate this? With Docker containers. So let's take a look at Docker. Now, I think as an industry, we've kind of gotten a feel for how containers work. So just quickly level setting. Docker provides a runtime for containers. Docker didn't invent containers, but Docker provides an elegant way to be able to run processes in a very automated and standardized way. How is this better than VMs, Puppet, Chef? Let's dig in. So isn't Docker just like VM++? Well, kind of. Docker is an ecosystem around container virtualization. So unlike traditional virtualization where we virtualize the hardware, with container virtualization, we are virtualizing the operating system, the kernel. So inside of Docker, we're running a process, not a machine. And then Docker provides this really elegant suite of command line tools that allows us to build them in elegant ways. Now, Docker isn't the only one that builds OSI compliant containers, but Docker is a really elegant tool chain that got the world started in this direction. Docker didn't create containers or CNAMEs or namespaces or jails. Docker just made this process really easy so that us mere mortals can spin up processes. Comparing containers to virtual machines, on the left, we have virtual machines. On the right, we have containers. This is definitely not to scale, but we can see that we're already leveraging our hardware a lot more efficiently because we don't need duplicate copies of the operating system. We're virtualizing the operating system here with this Docker hypervisor. Now, we still get the same level of sandboxing and isolation. Each container gets its own host name and IP address, but we don't need a copy of our operating system within it. Now, because we're virtualizing the operating system, the host running the container infrastructure needs to match the kernel inside the container. So for Linux containers, we need to run that on a Linux host. For Windows containers, we need to run that on a Windows Server host. Well, what's missing here? How about GNOME and KDE? How about Red Hat and Ubuntu? Do we need to host Red Hat containers on a Red Hat host? We don't, because we're virtualizing the Linux kernel. And the Linux kernel is the same kernel in Red Hat and Ubuntu. So we just need the pieces that are Red Hat specific and put those in the container if we're hosting a Red Hat container. Or maybe we can use a really lightweight Alpine-based container. And now our container is much smaller. Inside the container, we only need the differences between our host OS and what we run inside the container. Now, what else is missing? Well, how about Mac and Windows Desktop? Now, I went to docker.com and I clicked on download Docker for Mac. Are you telling me that's a lie? Well, kind of. On the right is how we do it in production. And we can see that we're using our system really efficiently. And we have as many containers as we need to be able to host on our host OS. In development, we may choose to do it like this, where we create a really lightweight Linux virtual machine using our standard hypervisor. In Windows, this is Hyper-V. In Mac, this is HyperKit. And then inside that Linux virtual machine, we can install the Docker hypervisor and run our Linux containers there. Now, if we are running Windows containers, we'll probably run it like this on our Windows desktop. But for Linux containers on Mac and Windows, we'll run it like this. Now, because we're using Hyper-V, we could also run other virtual machines as well. The beauty here is inside of WSL2. WSL2 is this guest operating system, and Docker Desktop installs really elegantly right on top of it. That's cool. So we've got Docker. Let's take a look at that Docker ecosystem, the process that makes this so easy. We start out with a Docker file. The Docker file is configuration as code. This configuration as code lists all of the steps that we need to be able to build up our containers. We'll take that Docker file and we'll build an image. Now, this image is the binary blob. It contains all of the config details, all of the application code, all of the dependencies. We may choose to share this image with Docker Hub or another container registry, and we may choose to pull images from Docker Hub. Now, the cool part about this, if I pull down an Ubuntu image, I don't need to recompile it. It is all of the content that I need to run. Now I can take that image and I can start it as a container on a Docker hypervisor. I plug in Ethernet, I plug in power, and now this container is ready to go. That's the Docker ecosystem, and it makes it really easy to take this very small Docker file and turn that into an image and run that as a container. If I want to do that with many containers, I can grab a Docker Compose file to build many images and start many containers, or I can use Kubernetes YAML pieces to be able to identify the images and start my pods with containers running inside them. So devs are building images already. Here's a Docker file that will build a .NET image. We start with a Microsoft base image, so we're standing on the shoulders of giants. We'll copy in our source code, we'll build our dependencies, and we'll ultimately run our site from this image. Each of these steps in our Docker file identifies the details necessary for us to get from starting with a thing to that final image that we're able to run. And then this final CMD command is that thing that launches this image as a container. All the rest of these steps are done at build time. So as I start the container, I just launch my website. Now, devs are already building these images. We could take a look at the details, and for the sake of, actually, let's do it. So let's come to hub.docker.com, and I will search for .NET. Now here in .NET, we can take a look at various images. Let's take a look at the ASP.NET image. Now here inside the ASP.NET image, we have .NET 5 and .NET 3.1. Scrolling down some more, we have a list of the tags associated with this image. So I could run ASP.NET 5.0, or I could run it on Alpine or on Ubuntu. I get to pick the details of the content underneath it based on the tag that I choose. So let's open up this Docker file and take a look at it. Well, this Docker file, we specified from this base image, and they specify from this image. They're going to add some more steps as well. So heading back, here's the .NET runtime image. Let's go look at that .NET runtime image. We can come in here to the runtime, and we can take a look at the tags associated with runtime. And they add some more content in for the .NET runtime. Now, this doesn't include the ASP.NET web features, but it does include the .NET Core runtime. So that starts from runtime depths. And we can traverse this through to all of the base images that we're looking for. Now, the beauty here is that we stand on the shoulders of giants, pulling in the resources from Docker Hub that we need to. We can build our own Docker file to do really interesting things. So here's the Docker file. Now it has this CMD. We expose 5,000. Here's each of the lines that we have in our Docker file. And each of those will create Docker layers that are cached independently. So once I have this layer on my machine, I don't need it again. Whether I'm running 2 or 5 or 100 copies of this website, once I have this layer in place, I'm good. So once I have the ASP.NET runtime patched at the version that I'm using, I have that runtime and I don't need to copy it. Turtles all the way down. As we launch it, we will get a new read-write layer, and that's what makes it from an image to a container. Each container will get their own read-write layer because it turns out writing to a disk is kind of important for log files and other things. Running as a read-only file system is a little hard on some applications. So each container is going to get their own read-write layer. And once the container ends, then that read-write layer goes away. Spin up a new container and I get a new read-write layer. But all of these layers with all of the rest of the content are already there. We can leverage this caching mechanism to ensure that we don't need to re-download all of the pieces every time if the only thing that we're changing is the published content. Layered file system. That Docker magic is so cool. We spin up hardware fast. And I use hardware in air quotes because, well, it's more of a process and less of hardware. We still have that sandbox isolation. We have a unique host name and IP address, but it's only a process. Imagine the difference between starting Excel versus booting Windows. Now, the Docker magic is really cool. What's particularly interesting about this is we can use the same tool chain between dev and ops. Dev can treat this as inside the container. Let's arrange all of the content really nicely. Let's decorate this table and put our config file in exactly this folder. Once we've got that done, we can close the door on the container. And now on the ops side of it, we can use the standard hooks and the cranes that we have in the yard to pick up that container and to stack it nicely on the ship. Ops will just boot the process, putting in Ethernet and power and being able to control that process so that it doesn't exceed the memory and CPU limits that are set. But the magic here in containers is that we're running the same tool chain. Do you remember that big 10-page document of how to deploy all the pieces? Yeah, that is gone. The developer can say, here's a container. Can you start it? And ops can say, sure. I'll plug in Ethernet and power, and I'll start it 3 times. Now it's load balanced. Docker Hub. We have .NET Core, Node, PHP, Ruby, Go. We have lots of different frameworks that allow us to build applications. And we also have lots of data stores: Redis, PHPMyAdmin, WordPress, Postgres, and SQL Server. Here on Docker Hub, we can take a look at the SQL Server container. Now, this is MS SQL Server Linux, so it is SQL Server running on Linux, but I can, and it's in a new page. I can use this SQL Server image to be able to run SQL Server inside of a container alongside my application. Now, I do run it passing in some interesting details, but ultimately, I've got the same mechanism for being able to start this process really easily for SQL Server that I do for applications. That's perfect. So let's leverage this. Let's take a look at running SQL Server inside of a container to facilitate our DevOps process to get production data into the hands of developers and pre-prod environments in an automated way. Now, SQL Server, if you're going to do it in production, you should use a database as a service. Azure SQL Database, Amazon RDS. That mechanism allows you to outsource the uptime and the point-in-time recovery and the authentication mechanisms. Outsource that to a provider that you trust. If you're running on-premise, then, well, you're probably running inside virtual machines. Remember the day when you couldn't run SQL Server inside of a VM because it just didn't work? Well, yeah, that day is not today. We no longer run SQL Server on bare metal machines. And so the day will come when on-premise we'll run SQL Server inside of containers as well. That day may not be today, but it's probably coming pretty soon. SQL Server in dev and test. Now, inside dev and test, we have different goals. Maybe throughput is not our primary objective. Maybe point-in-time recovery isn't as important because, well, we're in a pre-production environment and we can just blow it away and restore last night's production backup into place instead. So what we want in this process? Well, we want something that can run on a developer's laptop, where they can grab last night's production backup, where it's anonymized, sanitized, and shrunk appropriate to that environment so that we're not leaking production secrets and we ensure that this data is safe. And we want this process to be automated. I don't want to have to wait for the developer to say, hey, I just burned down my environment. Can I get a new one? Well, let me drop everything and solve your problem. Instead, we want an automated process that automatically takes last night's production backup and makes it available for you developers today while I'm asleep. So let's take a look at a mechanism to build this DevOps pipeline to get production data into developers' hands. Now, the code for this is inside GitHub, and I posted that link here in chat. And it's also available as you click through from robrich.org. Now, there's a web app associated with it. There's a schema that defines the database that we'll look at, and that's pretty interesting. But we're going to dig into the database folder. Let's start with this application. Now, I'm going to take a look at this application, or this database, and let's see what's in there. Here in this web app database, I have 3 tables representing all of the other tables that I might choose. Here's the customer table. Now, thanks to randomuser.me, these are not actual users, but rather randomly generated users from this API. Now, we can see that we've got an email in place here. I probably don't want a real email associated with my users, because if my developer is running a email test mechanism, I don't want them to accidentally email real users. Based on privacy concerns, I may also want to scramble their name or other personal details. Next, we've got invoice log. Now, this table might get pretty big. I have a lot of invoices, so I might want to trim out the biggest few. Now, not the top biggest, maybe not the top 5 biggest, but let me trim the orders for customers 6 through 10. Now, I don't want to trim all of the orders older than a certain date. That would be bad. I'm creating an artificial mechanism. I don't want to go re-normalize all of the invalid data. I want users to be able to hit that invalid data and to be able to experience the things that they've got. But I definitely don't need all of them. I can get the database to be a lot smaller if I trim out some of these bulky invoices. And next, let's look at the settings. Now I have an API key. Here's a production secret. I definitely don't want to get that into developers' hands. That is only for production use. Maybe developers don't even know that this secret exists or what the production value of this secret is. I also have a build date secret just so that we can see that our process is happening, but this isn't necessary in a production environment, but it'll be nice because right now it's set to January 1st, 2018. And over the course of this demo, we'll see that as we get to development, it will show right now. So let's dig into the process. What do we need to be able to do to get from production to developers? Now I'm going to pop open this file here, prod to dev.sql, and let's take a look in it. So let's start by restoring our production database backup. Oh, let's actually run our production database backup. So here's last night's production backup. Yep, that backup worked out well. And so we set that backup right here into this folder. Here's that prod database backup file. Okay, so let's restore that prod database backup file and we'll just set it in place. Now we need to do that sanitize, anonymize, and shrink process appropriate to each environment. Let's start by sanitizing the data. Now we're going to set this email to a random email address at contoso.com. So that way, if my developer accidentally runs a test that happens to send actual emails, it won't send them to real users. Next, I'm going to update the settings. I'm going to set my dev safe secret for the API key, and I'll update the settings where setting the build date to right now. So I've done the sanitize, I've done the anonymize. Now let's shrink. Let's go delete some invoices where, in this case, 1 equals 0. So yes, I'm not deleting any in this case, but we can go find those big bulky things. We won't delete all of them, but maybe we'll truncate logs. Maybe we'll delete customers 6 through 10 and hopefully shrink the size of the database without changing the shape of the data. We do want that really, really big customer to be able to make that page timeout so the developer can optimize their query. Next, I'm going to alter the database. I'll set it to recovery simple and shrink it so that that data that I deleted now makes the ultimate file size smaller too. Now, I definitely don't want to give them the production password. So let's change the app user password, the one used by the application, to a dev safe password. And I'm also going to change the SA password to that dev safe password as well. Now, in this case, I chose the same password, but you might choose different ones. Now, if they need to be able to create new schema, if they need to be able to do other tasks, they can log in with SA to this, their local development database. I'm definitely not going to give you SA password in production, but here in your local environment, yeah, do whatever you need to do. Now, how do we get this into Docker? Here's that Docker file. Now, this is configuration as code. Much like an application, we have those standard steps where we can copy content, run processes, and all of this happens at build time. So let's start out with SQL Server. In this case, we've got SQL Server 2019, and we will accept the EULA and set our password. Then let's copy the prod database into place. Now, we might choose to use the volume for this so that we don't need to copy, but either way, we've now got that database in place, and let's go copy that script into place too. Now, I'm going to start SQL Server, accepting the EULA and sleeping for 80 seconds, giving it a chance to spin up. Sometimes it spins up as quick as 10 or 15 seconds, but of course, because I'm screen sharing, it may take a while. So let's wait 80 seconds for it to start up. Then I'll run SQL command. and I will use that username and password. Now, probably I should use the variable passed in here rather than hard coding it again. And I'll run that prod to dev.sql. And then ultimately, once that transaction finishes and is committed correctly, then I'll kill SQL Server. Now, killing SQL Server, the SQL Server container does does catch that kill signal and will correctly shut down the database, finishing all of the transactions on the way down. Now here we're going to use a multi-stage build because turtles all the way down, each of these layers is cached. So I still have the production database backup stored in this layer, and this layer will change that production database, but I need to start over. So let's create a brand new container. We'll accept the EULA. The SA password is already baked into the database. We did that here. And then we'll copy the data from the var opt MSSQL directory from this container into the var opt MSSQL data folder in this container. And we're copying it from build rather than the processes here where we just said copy. Now, where is build? It's this container right here. So now this is a really, really small, concise container that a developer can use in a really elegant way. So let's do that. Now we're here in this directory. We've got that production database backup, and let's do that. We will say docker build -t dev database and dot. Now it is using the cache of a few things, but we do have a new production database. So we've invalidated that cache layer, and now we're starting up our database. Now, the cool thing here is that this is SQL 2019, and on my local machine, I'm using an older version of SQL. So on the way up, we'll see that not only will it grab that database backup, but it will also upgrade it to the latest version of SQL Server. Here it comes. Oh, it's almost there. There we go. Now here we go. So it's upgrading from 897 all the way to 904. Now it's booting SQL Server and it's getting it ready to go, booting up each of the databases. Then it will run our script that will anonymize, sanitize, and shrink the data appropriate for this environment. So yeah, as we're building this, we'll probably build a prod to dev.sql and a prod to qa.sql and a prod to dev-test-server.sql, a prod to preprod.sql that may choose to anonymize, sanitize, and shrink the data differently. In this case, we wanted to be very aggressive as we get this data ready for developers. And so we've chosen to anonymize, sanitize, and shrink a lot. So we've got our content ready to go, upgrading our database backup to 904, running all of our queries. We've then copied it into the new container with just those details that we need for this particular database. And then we've got our container all ready to go. Nice. Docker image list. So we just built this dev database. Now it is a little bit big, 1.59 gigs, but remembering those layers, a lot of the layers associated with this are Microsoft SQL Server's layers. So we don't need to update those every night. We only need to update the database backup content. Now, depending on the size of our database, it might be large. And thus, we may need to tune that anonymized sanitizing and shrinking process to make it appropriate for each environment. But now that we've got the database ready to go, then let's run it. Docker run -p 1433 to 1433, mapping from my local machine to the container. And let's start dev database. Now, if I had something running on 1433, then I might need to change it to 1434, 14330, whatever we need to do. But this now starts up this container that I can use for my development environment. Now, in this case, rather than running on Docker desktop, I'm running inside of Minikube, a separate virtual machine. So let's go connect to that Minikube database once we've got it booted up. And we can now connect our application to this dev safe database. Let's take a look. Connect database engine, I will choose Minikube and log in with my DevSafe password. I no longer need my production password. And now we are connected to this second instance. Let's take a look at the databases. Now, depending on the size of the database, it may take a minute for this database to come online as it copies this up to the next layer. But now I have all of my tables. Here's those three tables: customer, invoice, and settings. Let's create a new query and do those same queries into our database. So I've got my content. Let's use our web app database. And let's take a look at the customers. Now, previously, we had email addresses, and we were really worried about accidentally emailing our customers. We can see here that we now have anonymized email addresses. We might choose to anonymize other details like credit card or other personal information to ensure that that data doesn't leak outside of the production environment. Let's take a look at invoices. Yep, we've got the invoices in place, and we've truncated this nicely to the size that we needed. Let's take a look at the settings. Yes, we have the DevSafe API key, so we're no longer leaking production secrets into a dev environment. And the build date is, well, right now. That's perfect. Now, when I want a new copy of this database, I can just do a Docker container list, Docker container stop 6831, Docker pull dev database, and I can pull it from our registry to be able to get a brand new edition. Now that's perfect. As a developer, I'm now in complete control over how frequently I want to update and how frequently I need that new version of the database. And if anything goes wrong with this database, I stop it and I start it again. Now, we've been able to create this DevOps pipeline to be able to build a dev-safe database in a really elegant way. Let's kick this off from Jenkins or GitHub Actions or Azure DevOps whenever our production database backup finishes. Now, we'll probably need to run it a couple of times, once for developers, once for our dev test system, maybe once for a pre-production system. But remember that our database backup is only as good as the last time we restored it. And we restored it every night in an automated process. We've just validated our backup. That's perfect. And when the developer burns down his development database, well, we're still asleep. That's great. SQL Server on Linux. Now, the cool part that we did was we backed up our database from SQL Server on Windows, and we restored it with SQL Server on Linux. SQL Server on Linux is binary compatible with SQL Server on Windows, including SQL CLR. That's cool. We have the SQL Server agent, machine learning and agent-based replication are coming. There are some things that don't make sense on Linux. You know, those things that interact with IIS or Active Directory. So reporting services, analysis services, those things aren't on Linux. But agent jobs and store procedures, even in-memory tables and SQL CLR, all those features are available, and we can just back up our Windows database and restore it to Linux, and developers can continue on. Database DevOps. Developers are already using containers for their application. Let's let them use containers for their dev database as well. That's a lot easier than trying to walk them through the install process. Okay, now check that one. Nope, not that one. The next one down. Nope. Okay, now push next. Remember that process? Sounds a lot like that big Word document of how to deploy, right? We solved deployment with containers. Let's solve databases with containers. Create an automated DevOps pipeline to get your production data into developers' hands every night. This has been a lot of fun getting to share with you database DevOps for containers. For those of you watching later, grab these slides at robrich.org and hit me up on Twitter at rob_rich. For those of you here live in the conference, what are your questions?
Perfect. Thank you so much, Rob, and audience. This was a lovely presentation, isn't it? Time for questions. Please use the Q&A panel and you can ask your questions. Satya will pick it up from the YouTube chat windows and Slack channels. Any question on database DevOps? not just with containers, otherwise too. Right, Rob?
Yes.
Okay.
I often get questions about, well, okay, this gets my dev data from production into developers' hands. Do I need another database DevOps process to get schema changes from developers into production? Yes. And that DevOps process will probably run alongside your application process and probably looks a lot more like your application DevOps pipeline. You might choose tools like Redgate's SQL source control or SQL change automation to be able to grab those scripts, be able to validate them against a production database or a non-production database, and validate that those schema changes will work. Now, what's really elegant there is you can take this database that you backed up last night from the production backup, restore that as part of the build, run all of those migrations from this new DevOps pipeline that goes from developers into production, and validate the schema will work. Run all of the migrations, run all of the integration tests, and you've just, well, simulated a production deployment inside your database DevOps pipeline. When it comes time to push this into production, it's not new. You've already been able to flex this a bunch of times.
Absolutely. Okay, we are still waiting for questions to come in. Let me just check if, okay, the Q&A panel seems to be clear. Okay. Right, friends, and the links have been given by Rob to you in the chat window. So you can very well go and just download the decks and the content right up from GitHub and from Rob's website, the slides and the code, whatever he has shared.
One of the questions I often get is,
yes,
is this feature of SQL Server supported on Linux? For the most part, the answer is yes. We looked at a couple of scenarios where IAS or Active Directory is necessary for a feature where it just doesn't make sense on Linux. But for the most part, both Linux and Windows are first-class citizens in the SQL Server world. And so, yes, you can run that feature on Linux just as easily as you can run it on Windows. What are things that you might want to look at that are different between Windows and Linux? For the most part, the slashes go the other way. That's it. But probably as you're interacting with SQL Server, you're doing it from a database connection, not from the file system. So you just connect to that container name and, well, you're able to connect to it as if you would any other database. You might have a Docker Compose file that spins up both your application and the database and creates the service discovery links between them.
Perfect. Rob, there seems to be
licensing for using SQL Server and container. Great question. Now, one of the things that we did here in our code is we accepted the EULA. The one thing that we didn't do is set the MS SQL PID, the edition. Now, in this case, we chose the developer edition. That's the default. And the developer edition is free. So in non-production environments, using the developer edition for free is great. In production, yes, you do need to license SQL Server, and your standard audit process should be able to discover how many licenses you need. But in non-production environments, using the developer edition, there's no extra cost at all. One of the interesting things about Windows containers in particular, and I grant this is a Linux container, the question is, well, how do I license Windows? Well, what's interesting is when you license Windows, you're licensing the operating system. Containers share the operating system. Now, Microsoft could have made the choice to make you license each container, but they did not. Instead, you license the host. Once you've licensed the host Windows operating system, then all of the Windows containers that you choose to run on top of it work just fine with no additional licensing. Now, you may need to license the software inside of it. So for example, in this case, SQL Server, but using the SQL Server Developer Edition is still free. A question I often get is, how do I discover additional fields that I may need to modify? In this case, we had a very specific SQL script that modified specific columns. Now, how do we keep track of that? How do we ensure that new data is also mangled in similar ways? Yes, that is a burden. There are tools that can help you with that. Redgate SQL Data Masker is a really elegant tool in this space that allows you to be able to notice data that should be changed and to be able to change it in place. You could also choose to generate new fake data rather than just mangling the existing data. But you probably do need a process within your organization to identify which data is of what value and ensure that these scripts are kept up to date to ensure that all of those critical data columns get mangled in the correct way. I'll be the first to admit that oftentimes keeping these scripts up to date lags a little bit. And so the first time we add a new column and get it to deploy, we may end up leaking data. Now, hopefully we catch it really quickly, but ideally we're creating a commit to add that new column and to modify this production database backup script at the same time. At that point, the new column is modified as well.
Thanks once again for joining us and taking out your time for this session.